All right, here are the solutions for this Chapter 4 quiz about tangent, cotangent, and law of sines. It's kind of a short one here. First couple were multiple choice. You had to graph tangent in this first one here. So we just focus on this here, amplitude of 4. But the big thing here is the b. b is equal to 2. Remember, the period, t, is pi divided by b, pi over 2. Remember, for sine, cosine, cosecant, and secant, it's 2 pi over b. So this one's a little bit different. It's pi over 2. So I'm looking for a graph. And remember, tangent, it has this shape here. It looks like this one. But pi over 2 needs to be the distance between here and here. So like this one, for example, at the beginning, it's going from negative pi to pi. That's a distance of 2 pi apart. That doesn't work for us. This one down here, is, looks like we've got, well, looks like right around here to here is the period from here to here. But this distance from here to here would be, you can see this is a pi over 2 to pi over 2. So this is a pi over 4 to pi over 4. We're looking for that distance. This is way too skinny, so this doesn't work either. Here we have a negative pi over 4, and this is a positive pi over 4. So that does work. This is a possibility here for us. It has everything going for it. In this one here, we can see that it's shifted a little to the right, so that doesn't work. So our answer is C for this particular case. Now this one we have cotangent, and our B, remember we can write this as 2 cotangent of 1/2 theta. So our B is actually equal to 1/2. So the period is going to be pi over B, which is 1/2, which actually equals 2 pi. So remember, the shape for cotangent, it's not centered at the origin anymore. It has this shape here, like this one, where it goes from basically the y-axis over if there's no phase shift. So this distance from here to here, we're looking for it to be 2 pi. So this first one, you can see it's pi. So cross that off the list. This one looks like it's going from, we're going from 0 to 2 pi. This looks like it's a possibility, so we're going to keep this one open. This one, it's shifted over a little bit, so we're not going to use C. This one, definitely too small. 2 pi is over here someplace, and this is only has a period that looks like pi over 2. So it looks like our answer is definitely B here. It fits the bill, even though it kind of goes off the screen here. We can see that's where 2 pi was going to be at. All right, some other ones here. These ones you had to graph on a separate sheet. We had to use radians. So this one you can see we're doing with cotangent. B is equal to 6, so that means the period is pi over 6, and it's a negative 2 is our amplitude, which means it's going to be flipped upside down. So remember, a normal shape looks like this, where whatever the period is there, it's going like this with the asymptote here. So this thing's going to be completely flipped upside down and have this shape instead. And this distance from here to here should be pi over 6. All right, so let's just go off to the side here and graph one of these out, just so we can see. So we have graph that looks like this. I'm just going to do one wave on here. So this is y, and we're using theta for our axis over here. So I'm just going to go 4, 8, and I'm going to call this my pi over 6. So that's where my asymptote is going to be for this one. All right, so instead of it going like this, the way instead of it going like this is the way it normally looks for cotangent. I'm going to flip that around and go like this. Now, in terms of the negative 2 part, like how far down is that? Remember, that's kind of at the halfway points here. So if this is pi over 6, this would be pi over 12, and this would be pi over 24, and this would be 3 pi over 24 here. So at that point right there, that needs to be where our negative 2 is at, and over here it needs to be where the positive 2 is at. It's not super duper important to me. I'm more interested in that you get the period and the shape correct. And you could put a couple more in here if you wanted, but you get the general idea. The second one over here, number 4, we have tangent. So we have amplitude of 2. It's not going to flip or anything. You can see our B, since it's over 2, it's actually 1/2. So the period is going to be pi over 1/2, which gives us that 2 pi period again. Okay, so remember, tangent is centered at the origin, so that means for 2 pi I need to go pi to the left, or negative pi to the left, and a positive pi to the right of the center for this thing to be graphed properly. Okay, so let's go over here. We'll do one of these over on the side here. So remember, it was 2 tangent of theta over 2 is what we're dealing with. So let's just draw a graph here, some axes centered at the origin. I'm just going to go over 4 in this direction and 4 squares in this direction. It has to be 2 pi wide, so this has to be pi over here and negative pi over here. These are where our asymptotes are going to be, here and here. And the normal shape is going to be this shape here, or where it goes up and to the right. Now, if I want to take this 2 into account here, it means that this halfway point needs to be at positive 2 and at a negative 2. So I should hit this point and this point. So you can always put those in beforehand if you want. So it kind of gives you something to aim at as you're coming through here. So when you graph it, you can hit that point and go up. You could add some more of these if you want. Remember, this is y and theta for the axes. All right, well, let's look at the other problems here real quick. So these two problems, number 5 and 6, deal with law of sines, okay? So if you look at this here, it's asking us to find xz. That's this side over here. So I'm just going to call that little y, all right, because it's opposite angle y. So I'm just going to list what I'm given and what I need to find. I'm given that angle y, I'm just going to write it as a capital Y. You can write the angle sign if you want. It is 61 degrees. We have angle x is 80 degrees. We have that side z, little z, is 23. That's this down here. Z equals this. We could also figure out what angle z is, right? Because the big Z here, all I have to do is subtract from 180, these other two guys here, and you get that that is 39 degrees if you put all those together. Yeah, because these all have to sum up to 180 degrees, all 3 angles, of course. All right, but what am I trying to find? I am trying to find what y is equal to, okay? So if I'm trying to find y, but I have angle y, and I have side z and angle z, that's enough to use law of sines in this case. All right, so law of sines looks like this. I always like putting the thing I'm trying to find in the upper left corner. So I'm trying to find y. Underneath that, I have to say the sine of angle y, which is 61 degrees. And then I have to use side z, which is 23, divided by sine of z, which is sine of 39 degrees. And basically, I just need to rearrange this so that y equals 23 times sine of 61 degrees over sine of 39 degrees. And I just plug that all in at once. Let's just do that really quick on my calculator here. So make sure you're in degrees mode first of all. I am. So I'm just going to take 23 times sine of 61. Make sure you put a right parenthesis on that. And then divided by sine of 39. And we get about 31.96 to the nearest tenth. It'd actually just be equal to approximately 32.0. Okay, so we're able to use law of sines on that one. This other one here, number 6, is also a law of sines situation. Let's draw the triangle here. So this one, I don't give you the triangle, but you can draw it. Some triangle TRS. We got some angle T, it's 145 degrees, so maybe we'll put that down here. 145 degrees, angle T, and then we'll draw the rest of it in here. So that's T, let's call this S, and we'll call this, the other side is R here. So that means this is a little r, this is a little s, this is a little t. So if we fill in what we know, we're told that little t is 23, little s is 9. Not given r, but we're asked to find what is this angle right here. Okay, but I do have the side associated with that, the s side associated with that, and then I've got big T, little t here. So I actually have everything I need to set this up. I'm going to start with saying sine of s over the side s, which is 9, is equal to sine of side t, which is 145 degrees, or angle t, divided by side t, which is 23. And so I just need to solve this equation for s. So I get sine of s, angle s is equal to 9, sine 145 degrees divided by 23. So that means S is equal to the inverse sine of all that, 9 sine 145 degrees over 23. So you can plug it all into your calculator at once. Again, make sure you're in degrees mode. So I'm just going to do inverse sine, then 9 times sine of 145 divided by 23. Make sure you do parentheses correctly on this one or you get weird answers. And I get 12.97, which is approximately, that's going to be approximately 13.0 degrees. So this is an angle, remember, so you got to put degrees on it. And does that look right? We kind of drew this to scale. Does this angle up here kind of look like it's about 13 degrees? Yeah, it kind of makes sense. Looks about right. It's always good to check that. And then we had this bonus question at the end. Only thing I'll mention about this, I'm not going to do the graph of this, but since it's a negative 20, it's going to flip upside down. Normally, a tangent looks like this, so instead of like that, it's going to look like this. The period here, if we want to draw that in between these two, this distance between here, well, b is equal to 1 over 100, so the period is pi divided by 1/100th, which is actually just 100 pi. So that distance between these two would need to be 100 pi. All right, so that was just that quick little quiz we had earlier on. I'll be posting some other quizzes as well.